Hello, welcome to Unit 4. And this is a very short unit. We're just going to do some basics of the 4 transformations. They are translations, which means to slide. So let's put that on here. Really, these are just slides where you're sliding figures around the coordinate plane. We're going to do rotations, where we're turning figures on the coordinate plane. We're going to do reflections where we're flipping things, and we're also going to do dilations, which makes things grow and shrink. So first up is translations. So again, a translation is just a slide. So what you're going to have is some figure drawn, and it's going to be labeled with letters. I'm going to just make a triangle to make our life easy. So go ahead and draw a triangle just like that on your coordinate plane. I'll give you a minute to do that. We say that triangle ABC is called the pre-image. It hasn't been messed with yet. So we call it the pre-image, and the way you can tell that it's the pre-image is it's just labeled with a plane A, a plane B, and a plane C. And then what we're going to do with our translations is we're going to slide it. All right, so suppose we have to slide it all uniformly. So let's suppose I took point A and I moved it 4 to the right and 1 up. And when I do that, I call the new point A prime. And I'm going to go do that with every point. I'm going to take every point and move it 4 to the left and 1 up. And I'm going to label it with a prime. 1, 2, 3, 4 to the left, and 1 up. I'm going to label it with a prime. And I'm going to redraw that triangle. And we say that triangle A prime, that's what that little apostrophe means in math, is prime. We say that triangle A prime, B prime, C prime is the image. Under this translation? Well, when I describe the translation, I describe it one of 2 ways. I describe it with words. So let's write word description. What did I do to the triangle? I took every point and translated it or slid it 4 to the left and 1 up. So this translation is 4 to the left and 1 up. Now when I describe it algebraically or with coordinate notation, it went red on me here for no reason. Now back to blue, it's possessed. Coordinate notation, I tell you what I did with each point, and every point is considered x comma y on the pre-image. Remember, I took A and I moved it 4 to the left and 1 up. So I'd say every point got mapped to, that's what this arrow means, and when I moved it 4 to the left, that would be to subtract 4, and when I moved it 1 up, that would be to add 4. So left is subtract, right is add, up is add, and down is a subtraction in the coordinate notation. So let's go just draw a couple translations. They're pretty easy. I think I have one on the next page. All you do is move the figure as indicated. So on our first one here on the next page, it won't activate. There we go. And now it's going crazy. All right, here we go. We're going to translate this 4 to the right and 4 down, and we're going to label it accordingly, and then we'll give it its notation. First of all, let's write this algebraically over here. I would say I'm going to take every point, and I'm going to map it to a new point. From pre-image to image, it's going to go 4 to the right, which will add 4, and 4 down, which will subtract 4 from the y's. And now I'm just going to go move them that way. Let's start with J. 1, 2, 3, 4 to the right, 1, 2, 3, 4 down, call it J prime, done. I, 1, 2, 3, 4, 1, 2, 3, 4, label it I prime, done. A, 1, 2, 3, 4, 1, 2, 3, 4, label it A prime, and I have just graphed the image. This is the pre-image. This is the image under this translation in coordinate notation and that translation in words. Up next, we've got state the translation. So now I have to figure out what they did. Now this is where you have to be careful. Grab any point on the pre-image, and remember that's without the primes. Walk yourself to its image, which would go 1, 2 to the left, and 1 down. So I'd say this translation moves the figure 2 to the left and 1 down. And I didn't have to grab point H. I could have grabbed Y and done the same thing, and I would have still gone 2 to the left and 1 down. So any pair will work. Just make sure you grab the ones without the prime first. So in coordinate notation, I'd say every point X, Y got mapped to left is negative, down is negative. So I'd say X minus 2, Y minus 1, and I'm done. Moving on to a rotation. We're going to rotate one of 3 ways. We are going to rotate 90 degrees clockwise. So rotation, let's put its layman's term up here first. A rotation is just a turn. So we're going to be turning this thing. We're going to put it on a spigot and we're going to turn it. We're going to go 90 degrees clockwise. That would be that direction. We're going to do 90 degrees counterclockwise. And counterclockwise goes against the clock, so it goes that way. And then we're going to do a 180, and a 180 just goes to the very opposite. So a 180 clockwise and a 180 counterclockwise are the same thing. And we're just going to rotate what we would say about the origin. So we're going to just pretend we're rotating it about a fixed point, and our point that we're rotating about will be the origin. So the first thing I'm going to do is, instead of giving you a whole figure, I'm just going to give you a point. I want you to go plot the point 5, 2. 1, 2, 3, 4, 5. 1, 2. Put a big dot there. We're just going to see what happens. Let's label it point A. When I attach that on an invisible piece of string, I'm going to draw it, attached at the origin, and I rotate it 90 degrees with the clock. And we're going to kind of guesstimate. Now here's the deal. For lines to hit perpendicularly, like a 90-degree angle, because I'm going to make sure I hit at a 90-degree angle, their slopes are opposite reciprocals. We've talked about that, I believe, in another section. The slope of this line is up to over 5. Its reciprocal would be 5 over 2, and if I flipped it, that's what I'd have. So if I go down 1, 2, 3, 4, 5, and over 2, I get this new point. But see, we don't want to always have to do that. We want to come up with a rule. So there's my 90-degree clockwise turn, mapping A to its image, A prime. But look what happened to the points, and it'll always happen, so watch. The point 5, 2, and I'm going to write it small up here, got mapped to under a 90-degree clockwise rotation, so I'm just going to put C. It got mapped to the point 2, negative 5. So look what happened. In general, we have a point XY. What's going to happen under this rotation is the Y now comes first, and then it went to the opposite of the X coordinate. So if you can just use this, and let's put it in a box, that'll allow you to easily rotate things without having to use slopes and all that kind of stuff, because that's what's always going to happen. So let's go erase that, and I don't want you to plot this next point, but watch, what if I said, how about let's take the point -3, 6. There's that 7 up there. I'm not sure. 1, 2, 3, 4, 5, 6, 7. Okay, so I've got the point here, and just watch. This is the point -3, 7. Under a 90-degree clockwise turn, what this is saying is it's going to go to the y value, right here, look where I'm putting a dot, and then the opposite of x. So it's saying it's going to go to 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. And look, if I attach it on a string, I've got a 90 degrees clockwise rotation. Kind of cool. So our next one, let's go back to that original point I told you to plot, 5, 2, 1, 2, 3, 4, 5, 2, right here. And now I'm going to attach it on that invisible string, and I'm going to go 90 degrees this way. And you can kind of see, like, I did it really quickly, but I actually landed in the right spot. And what I've got there is 5, 2. When I went against the clock, look at what it went to. It went to -2, 5. Well, let's write that with coordinate notation. That means any point under a counterclockwise rotation is going to get mapped to the opposite of y, because you can see I went the opposite, and then I kept the x intact. So that allows you, and you can use these in your notes and on your test. You don't need to memorize that. The last one, let's go back to our original point, 5, 2. We're going to do a 180. A 180 is a straight line. So watch, if I do the straight line there, 5, 2, it's going to go right over here, straight across. That's your 180, and that's why it doesn't matter if you go counterclockwise or clockwise, because it's the same either direction. So what happened to 5, 2 under my 180-degree turn is it went to the opposite. Nothing got swapped or anything. So that's what we're going to write for our rule. It takes every point x, y, and maps it to the opposite of x and the opposite of y. By the way, a 90-degree counterclockwise is also a 270 degrees clockwise, because remember there's 360 degrees in a circle, so it would complete the circle. So let's go take a look. This just says do a 180. It's just going to send it to its opposite coordinate. So I'm going to go label these. P is at 1, 5. On a 180, it's going to go to -1, -5. And that's my new P. So I'm going to have this whole figure do a 180, which basically sends it through the origin. Look, you don't need to draw that on yours, but you can see that. It did a straight line turn right through the origin. We're going to take K and do a 180. K is sitting at 3, 0. So it's going to go to -3, -0, and I'm going to call that K prime. F is at 1, 2, 3, 4, 1, 2, is at -4, 2, so it's going to get mapped to the opposite, 4, -2. I'll go over here, and I'll call it F prime. They're all just going straight through the origin to the opposite side. So, which one haven't I done yet? N. N is -1, -2. So it's going to go to +1, +2. It's going to go right there. And I'm going to take my road map out of here. And that one will be called N prime. And so I'm going to connect my new figure. And I've just done a 180. Basically what I've done is just turn that thing around on a half a circle. So this one says to go 90 degrees clockwise. So if you go back and look, you don't really want to try to do every point on, let's go take, here I'll show you. Let's go back because we don't want to have to reinvent the wheel. We have a pattern for it, so we're going to write it. It goes to, right here, y, the opposite of x, on a 90-degree clockwise turn. So let's go do that. On a 90 degrees clockwise turn about the origin, every point is going to go to the y opposite of x. So what we should probably do is write the coordinates down. I think that'll be easiest. So we've got y sitting at 4, 3. Erase the map. We've got k sitting at, right now, 5, 3. We've got B sitting over there at 5, 0. And we've got U sitting at 2, -2. That's where they are now. Again, we call that the pre-image. We are going to rotate this 90 degrees clockwise. So we're going to take every point and send it to the y value opposite of x. So we're going to do y value, y value, y value, y value, opposite of x, opposite of x, opposite of x, opposite of x. We're going to replot and reconnect. So my new y is going to be at 3, negative 4, right here, and I'm going to call it y prime. I should probably put its title a little closer to it, right? Y prime. Now look, don't draw this in your notes, but if I attach it on that invisible piece of string, you'll see I've got a 90-degree clockwise rotation when I connect them. It works like a charm. Just follow it like a map. So my new k is going to be at 3, negative 5. 3, negative 5. My new b is going to be at 0, negative 5. 1, 2, 3, 4. Oops, 0, negative 5. I'm not counting right. Here, just a second. 1, 2, 3. There we go. This is my new y. This is my new k. This is my new b. And my new u is at negative 2, negative 2. And when I connect them, I get the exact same figure. It's all just been turned and a 90-degree turn about the origin. It's all gone 90 degrees in that direction. Now when you're trying to figure out what the rule is, just a second. All right, so when you're trying to figure out what the new rule is, what you're going to do is grab a point. Let's grab k. We'll put it in red, I think. I'm going to go look at k prime. And it's easiest just to attach it with its string to the origin, and then you can see that this is a 90-degree. You just need to do one point to its new image. Now be careful you grab the non-primed one first, or you're going to have it going backwards. But this is obviously a 90-degree clockwise rotation, technically about the origin. So a 90-degree clockwise rotation. And that's it for this video. Next up will be reflections and I believe dilations.